you have to know about long-term potentiation, which is essentially when you get repeated stimulation of the neuron, you get that particular process. And the way it works is, I don't think you need to know much about it for A level, except the fact that the calcium ions are involved. So I think what I'll do is I'll probably leave it at that. This is the review, which I think is excellent. Please download the PowerPoint and copy and paste that link. This is a 2012 paper on calcium dependent and NMDA receptor dependent LTP, and it explains it a lot better than I can, and you have to know that for university level neuroscience. For A level, not really. I mean, you know, we have neuroplasticity in the brain. There's a change in the structure, the morphology of the neuronal connections, which is based on whether or not we have repeated stimulation to neurons. I mean, Hebb said in 1940 something like neurons that fire together wire together, and we've had other work by Bliss Lomo on this in the 1970s, looking at the molecular basis of LTP and the electrophysiological basis of LTP, especially in the hippocampus, and that involves the calcium ions as well as sodium and potassium ions, and the NMDA and AMPA receptors molecules. And I will actually, what I'll do is I'll do another video on let's see, probably in section 5 on cognitive neuroscience. I'm going to revisit that concept, or subtopic rather, because it is important in learning and memory, and I'll cover it again in, I think, section 5, cognitive neuroscience. So that's all I'm going to say for now. Look at that link. All you have to know is that basically, if you have a connection between one node and another node, between A and B and B and A, that right there is what we call learning. Okay, you strengthen the connection, that is learning. And we will talk about it more in cognitive neuroscience. And we'll also talk about it more in section 6, which is computational neuroscience and neuroengineering and systems neuroscience. Yes, I think I'll leave it for these videos, because for now, I mean, that's it for now. You don't have to more than this. And the other thing, because I wanted to move on to neural networks pretty quickly. So we have different types of neurons, which are excitatory or inhibitory, and you can connect them together into networks of neurons. There are not infinite, but the number of combinations of different types of neural networks is just absolutely huge. I mean, you can make, these are just 5 neurons, and you can connect them in I don't know, thousands of combinations. I mean, just add a few more neurons and a few more connections, and it gets a lot more complicated, let alone 100 billion neurons with 100 trillion connections. I mean, that is mind-blowing, I would say. And what I want you to understand is we have the molecular basis of neurons, underpins their physiology, which underpins their function and how they communicate with other neurons. Okay, you have to know these. If you're at university, you're writing essays, you have to know these papers and reference them, and know what the experiments that they did, because that's how we write essays in neuroscience. Young, J.Z. Young, Hodgkin, Huxley, Goldman, Keynes, Armstrong, and so on. Let's see who we have. Many others. Just look these up. These are key seminal papers. You have to know. Some of them are probably, and by the way, they're kind of old school. They're like from 1930s till 1990s. But if you're on more recent ones, they're not that recent either. But look these up as well. And websites are good. You can look up Neurochemistry Journal, Neurochemical Journal. The Scientifica is useful. The NIH website, LTP, look that up. Action potential, simulations and animations. Just Google on YouTube. It's got videos on animations at the UCL websites, because I have a degree from UCL.